So here is the image of an outer rotor motor, and it's basically the wheel of a bicycle. So on the center part of the bicycle wheel, here is the motor, and basically this motor is similar to this kind of a construction. So what you are able to see over here, these are the permanent magnets, and these permanent magnets are basically present on the periphery of the rotor. And here whatever you see in the white color or silver color, these are the segments of permanent magnets. So here are the permanent magnets, and here you have the stator, which is going to be fixed with the axis of the bicycle. So the bicycle center part of the wheel will remain fixed, and that is going to carry the windings. So these are the slots, and these slots will be actually creating the windings. So here these are the windings or the copper material, and this is how you can basically configure your motor. So this blue part is basically the windings, and you can decide the number of conductors you have for slots. And over here what you see is 3 Hall sensors mounted over here. So this is basically a brushless DC motor for a bicycle application. So, and similarly for scooter and other application, even for high power application, this kind of motor configurations are popular. Let's go back to Ansys and understand about the configurations, and let's actually work out the solution for the given example motor. So here I have opened the first example of adjustable speed synchronous motor, and in order to run the analysis, basically we are going to create multiple files in the same folder. I'm going to save this project into a different location, so I can click on the save as, and I can decide on saving this to my working folder. So let me create a new folder over here, and I'm going to save this into a new folder. So after I have saved to another location, now I will be able to modify the parameters which are read only. So here the things which you can do the analysis and generate multiple files, which will be now possible, and you will be actually saving a copy of the default examples which are supplied with the software installation. So in order to run the analysis, what we are supposed to do is we need to understand the setup of the simulation first. So if you see this setup over here, basically we are going to consider the operation as motor, and we are going to consider the load, which is a constant power mechanical load, and we assume that we have the 550 watt output at 220 volt, and the rated speed is 1500 rpm, and the motor is required to operate at 75 degrees centigrade. So these are the analysis setup which is already done. So if we want to run this, we need to right click on the setup over here, and the setup option is available over here. So just right click on the setup and create and click on analyze. So here is the analyze option, and you can click on that, and this analysis will be done. So when I click on analysis, here is the progress which you can observe over here. In this window, the analysis is running on the local machine, and you can see the progress with this. So basically the analysis has finished, and we can now see the results. So how do we visualize the result, and what are the message manager, right? So here is the message which we have received, and if you see this, the normal completion of simulation on server has happened. So if we see this and try to understand about the results which are produced. So we need to right click on results and click on solution data. So when I right click on the results, there will be many options opening up, and I can click on solution data. And when I click on solution data, I will be able to look at the results of this simulation. So basically, if what you see in this window is the solution. So this is a solution window, and what we are able to see is the finite element analysis input data, and there are many other data available over here. So the full load operation in terms of losses, in terms of different types of losses, and value of the current, and the value of the rated torque, and so on, can be seen from here. So you can actually understand about the material consumption as well. So for the given dimension and for given configuration of the slot and the type of rotor, how much is the consumption of your material. So basically this will really help you to understand quickly about how much is the material required. And there are other parameters as well, such as rotor data, such as permanent magnet, and you can basically understand about what happened to permanent magnets. And there is a design sheet generated, and you can actually copy this design sheet and try to incorporate into your design, which is going to be your very first jumpstart design. So here is the full load data, the iron core losses, total losses, output power, the efficiency value at full load, and the air gap flux density, the stator teeth ampere turns, and so on. So here is a complete design sheet of the motor available to you, and there are actually many parameters which are considered as your input. So whatever we have given as a input in the case setup, that is what is reflecting in the output. So you need to decide about what kind of case you want to set up. And if you want to plot the data, it's also possible to get the value of current over the torque angle. Basically these are electrical degrees, and if you consider the number of poles, 180 degree over here can be equivalent to the 360 degree mechanical if you have two number of poles. And this input current versus torque angle, which is varying like this. So if you have efficiency versus torque angle, this is the plot which is available. And if you see the air gap flux density, which is varying like this, and you can see the different types of plots. Now basically this is all simple mathematical calculation, and you can see the winding currents under the load. So these are the value of the current flowing from the stator winding, and these are according to our assumption of the control type of the motor. So what is the control type of the motor? It is basically defined over here, and it's a DC control type. And you can see the circuit type and other parameters which we have given as input. So you can change the control type, and the current excitation is going to change. So this is about the first analysis which we have done with the RM Expert. Now RM Expert is just kind of a calculator with a decent GUI or graphical user interface. Now what can be done further? Now can we know that whether this permanent magnet is fully utilized, whether there is going to be a saturation of the stator core or rotor? In order to understand all minute details of the motor, you can actually go to the next level of analysis, which is known as Maxwell analysis. So from RM Expert you can actually develop this motor, and you can know about how this motor is going to function with electromagnetic analysis. So this is an analytical tool, and we are now going to switch to the Ansys Maxwell. How do I generate an Ansys Maxwell design. To create the Maxwell 2D analysis, I need to right click on Analysis and click on Create Maxwell Design. So if I select Analysis over here and choose the option Create Maxwell Design, it will open a new dialog box. So basically I can select the setup and give a name to that setup, and I can basically provide a variation as well over here, and I can decide whether I want to get Maxwell 2D design or 3D design. So let me generate a Maxwell 2D design for this standard motor. So if I click on OK, now automatically the design will be created, and there are multiple files which will be added into our project manager. So what you are able to see over here is the RM Expert is creating design on its own related to excitation, related to its geometry, and related to material assignment as well. So whatever you are experiencing, this all process you might be required to do manually if you do not have this software feature, and basically you can do many more analysis from this tool as well. So if you see, the entire 2D design has been generated, and you can see in the project manager there are a lot of things available. So in order to do this, there are many empty plots which are created. Let me close that. Because we haven't run the Maxwell simulation, we are not getting any result now, but when we have some kind of analysis done over here, we will be able to see some results. So if you see over here, we have around 1/4 part of the motor available over here. So why do we have the 1/4 part of the motor? Because we can take the advantage of the symmetry of the motor and do the analysis at a much faster speed, so in less time basically. So if you see now in the project, what we have added is the RM Expert design which was earlier present, and we have added the Maxwell 2D design as well. So now let's focus on what is there in the Maxwell 2D design. So if you see over here, there are models, there are boundaries, excitation, parameters, and meshes created, and here are certain analysis and optimetrics as well, and results will be available over here. So this many results are available once you run your 2D analysis. So, and what you are able to see over here, so these are basically the materials which are assigned to the geometries. If you have done any analysis with the 2D software, you will be knowing that how do you create the geometries. So basically you develop a circle, then you cut out the circle from the bigger one, you make something similar to the stator part, you have the rotor circles, and then you have the permanent magnet, and then you add windings, or we can say the coils, and there will be slot and tooth arrangement. So these are the geometries which are created. Not only the geometries are created, the materials are also added by default. So if you click on coil 1, this is going to be activated. So this is the coil 1, here is the coil 2, and here is coil 3. So if you see this coils, basically these are the 3 different phases, and here is what you have as coil return. So if I click on over here, this is a coil return, and this is also the coil return, and if you see the material type, this is M1924G, which is the material assigned to this area which is highlighted, and this is basically the vacuum. And if you see the rotor, which is of this type, and this is the stator, and so we have the stator material, rotor material, and the coils. So these are the coil groups, and you can basically see the unite and subtract. Basically these are related to the geometry part. And if you see over here, there is a coil 0, and there are so many materials available over here. So this is really a complex structure. If you start building yourself, it may take a lot of time, and that is why the Ansys RM Expert tool is developed. So if you just put in your diameters and get quickly your 2D geometry ready for the analysis. So these are the copper, and these are the material. And if we see over here, this is the magnet part, what you see as highlighted in the pink color, and these are the materials which are added over here. So here are the coppers, here are the coils, and this is the coil 1, 2, and so on. And basically you can see there are multiple number of coils. If I keep on minimizing all this, so these are all the coils. Now over here, if I go to this model and if I see the boundaries and the excitation, so now if I click over here and try to see the excitation, where is phase A coil, phase B coil, and phase C coil, I can actually see those coils spread in the different parts. So I need to deselect this one. Okay, now and over phase C, this is the phase C. So over here, these are the phase winding excitations given. So all these things are readily available when you translate your RM Expert model into a Maxwell design. So this is about the excitation, the boundaries, and the mesh. So here what you have is the main and the magnetic mesh created over here. You can basically configure that data from here. So let's now run the default analysis, and let's try to see the setup over here. So the setup over here is going to be the advanced one, and there are solver and general values. So how much is going to be the stop time and what is the step time, and you can basically do the high performance computation over here, and you can do this setup. You can run this setup 1. So when I right click on analysis and click on analyze, Maxwell 2D analysis is going to run on my computer. So if I do this, let's see the analyze, and here it's going to now take a bit long compared to what we have seen for RM Expert, because RM Expert was just an analytical tool, and now whatever is happening over here in the progress, that may take more time depending on the speed of your machine. So now the simulation has finished, and we can actually see some of the results now. So let's see what are the results available, and let's try to see the plots for the torque. If I double click over here, these are the value of the torque over the period of time, and these are the value of the current, and you can basically configure which currents you want to plot and what you want to add into the plot. So this analysis will now give you all detailed values for your motor. So the flux linkages over the period of time, it's basically the sine values, and these are the A, B, and C phase flux linkages, the value of LD and LQ flux in the D and Q axis. So over and above this, you can actually get to know about different things related to fields as well. So whatever is this field overlay will give you an idea about what are the fields available and how you can plot this. So if I'm interested to know about the magnetic field intensity, I can select the geometry and generate that plot. So I can select the stator and rotor and permanent magnet, and I can select the fields which are to be plotted for this geometry. And this is what are the options I need to select, and I'm interested to plot the magnitude of the B vector, and this is going to develop the plot for magnetic fields.